Hey there guys, welcome back to the YouTube channel. Today we're going to go ahead and shift to the CCNP Enterprise side of things. I've got a few CCNP videos planned, but this one's going to be about MST, Multiple Spanning Tree, and RPVST plus integration. So I do have to admit this is not my lab. I really like this lab. This is actually a CBT Nuggets Lab. They're apparently coming out with their ENCOR course very soon on CBT Nuggets, so if you're interested, go ahead and check that out. This lab is actually publicly posted on Keith Barker's YouTube channel. Keith Barker is an amazing instructor. I will have his channel and video again linked down in the description below. But this is one of the labs that he's shown off, and I found it really interesting. This lab right here integrates a couple of things. So switch 6 right here is part of the RPVST domain. It's the only switch in the RPVST domain. And then switch 1 and switch 5 are all in this MST region, with switch 2 and switch 3 being the root bridges for each respective instance. There's 2 VLANs, 2 instances, and switch 4 is the IST root bridge. So I'm expecting that you're going into this video with at least basic familiarity with MST and RPVST. It is very important that you do understand the fundamentals of MST, and that's something that I'm not going to cover here. I may make some videos in the future covering that particular aspect, but not today. So with that being said, I'm going to go ahead and transition to the GNS3 environment so I can show off what this lab. So while this lab powers up, I do want to go ahead and mention that the configurations from this video, both the base configurations and the finished configurations, are available on my GitHub. This is actually the first video where I'm implementing that kind of thing. If you want to replicate this lab on your own and experiment around with it and learn more, that's perfectly awesome. Check the link in the description below. There is a link to a GitHub repo. You'll find the configurations in there, and then you can either copy it in to your iOS configurations, or you can do what I recommend you do, which is actually do the lab, walk it through with me alongside this video, and then compare your configurations with the final configurations to see what, if anything, we've done different. It is important to note that you cannot do this lab on Packet Tracer, because Packet Tracer has, as far as I can recall, no support at all for MST. The last thing I wanted to do before this lab comes up is kind of go over the topology here. I've kind of tried to replicate as much of the interface labeling as I can, so these numbers are accurate. They correspond to what I have here in the GNS3 topology. So is this. I've even made the MAC addresses the same. I can't change the MAC addresses on my nodes, unfortunately, but the MAC addresses for the nodes don't really matter. It's these base MAC addresses that matter, because they'll influence designated port elections and root bridge elections. These requirements will be followed strictly. I actually have a printout of them, so I'll be walking through them as I go through this video. I'll be bringing the screenshot back up a lot, but this is the topology. You may want to remember it, and if not, I will be referring back to it a lot. So the first thing I'm going to do, the lab should be finished initializing now. I have done some setup. So the lab actually makes mention of, if you look, I should bring this back up. The lab actually makes mention of 20 and 40, even though there's actually no PC star part of it, but I'll create them anyway. So I've actually used VTP here to distribute this. Now VTP actually has some support for MST, but in this case I'm just using VTP to distribute VLAN information. So I've created VLAN 10, 20, 30, 40. If I show VTP, show VTP status, client, and if I go to switch 6, this is actually, switch 6 is actually my VTP server. Yeah, so this is my VTP server. It's actually my VTP primary server. So all of these switches, I'll just do switch 5 just to prove a point. I'll have VLAN 10, 20, and 30, and 40, and the appropriate ports assigned to each. I've also assigned a, I should really have done a regex here, that's okay. Have VLAN interfaces assigned, so 100, 100, 100 dot whatever switch number it is, so let's say 3. And this really serves, it's not a requirement for Galab, but it's there just in case we need to use it to validate some connectivity stuff. As far as I'm aware, that's basically all we've done, besides some interface configuration, some VLAN assignments. Nothing has all been done with regards to spanning tree. Everything else is basically as stock. I've even not removed these banners. So This switch 6, I'm going to start on because it's probably the easiest. Switch 6 is the RPVST switch. So the way I would configure RPVST, if I do a show spanning tree right now, you can see spanning tree enabled protocol IEEE. The way that I would configure RPVST, Rapid PVST Plus, which has some improvements that, again, I'm expecting you to come into this video already familiar with, but how you configure it is spanning tree, mode, rapid PVST. It's that simple. It's not nearly as complicated as MST config. But if I do a show spanning tree, you can see now I've got spanning tree enabled protocol RSTP. Switch 6 is done, for now at least, with the exception of I'm going to jump around with these objectives. So there is an objective where I bring back up this picture here that says that switch 6 should use rapid STP, so we've done that. But there is one here that says enable port fast and all access ports. So while I'm on switch 6, I'm just going to do that. So you can see on the topology, if I bring it back up, G00 and G02 are what I'm looking for. So if I go here, the command for that is config T, interface range. I could do individually, but I'm too lazy. Spanning tree port fast. Alternatively, what I could have done, no span port fast, is said spanning host, or not spanning host, switch port host, which will set the switch port mode to access, will disable the ability for you to do ether channel, and will enable spanning tree port fasts. It's a macro command, which is lovely because it'll just do switch port mode access for you. Same thing on switch 5 here. If I go back to the config 0002, so I'm going to do the exact same series of commands here, spanning switch port host. Now let's go and configure the MST domain. The initial step is similar to what you do with RPVST Plus. You see spanning tree mode MST. See if I can type. After that, though, it does deviate a slight bit because MST is not just a simple plug and play. There's actual parameters. It's kind of like VTP. You have to configure a domain and all that stuff. And unlike VTP, you can actually configure a revision number, which does not update dynamically and has to match. Lovely. There's also some other requirements for forming MST relationships between switches, but like I'm going to keep saying in the video, I expect you to already know that. But the command to enter MST config is spanning tree MST config. Right. There's some other stuff here, but here's what you're looking for. Spanning tree MST config. If I do a question mark here, you can see we have some interesting things right here. Mainly the name we're going to start off on first is CBT. The revision number, let me check my list again, is 6783. So these two are some of the things that have to match among our switches. None of these other things are really useful, except instance, but we'll go back to that in a second. So let's go ahead and just configure all of our switches to run MST. So span mode MST. I'm actually going to go ahead and open up a text edit document because I am too lazy to type all that. So we're going to say config T, because I don't know if these switches are already in it. Spanning tree mode MST, span MST, stop auto correcting me. Config, we'll say name CBT revision 6783, and then that's where we will leave it. So now all these switches are configured with MST. Now we're going to configure an MSTI, an MST instance. So MST, as you may be familiar with already, hopefully, does not directly use the concept of a VLAN. So if you'll recall, PVST plus 802.1d and RPVST plus 802.1w use the concept of a per VLAN expansion. If I go to switch 6 here, which I've already configured, you can see that VLAN 1 has a spanning tree, VLAN 10 has a separate spanning tree, VLAN 30 has a separate spanning tree, right? So every single VLAN that's configured on a switch has a spanning tree instance configured for it. Not so with MST. MST's goal is to consolidate, and a Cisco switch anyway, is to reduce the number of spanning tree instances they have to run, reduce the redundant spanning tree instances that are just unnecessarily taking up CPU time, and therefore making spanning tree more efficient. How we do that is specifying an instance, and an MSTI is similar to a VLAN and RPVST in the sense that there is a spanning tree instance that has run for each instance, for each MSTI, but instances can contain multiple VLANs. So you can have a spanning tree instance now that is over multiple VLANs instead of just having one per VLAN, which is often really wasteful because you might have paths that are the same between VLANs. Again, look in more detail about MST if what I just said confused you. But the instance has an ID, right? It's not a name, it's a number. So if we go back to requirements, it says that instance 2 has a switch 2 root bridge and VLANs 10 to 20. The instance database is one of the things that has to match between switches and the MST domain. So switches 1 to 5, if I configure an instance 2 and an instance 3, which contains VLANs 30 and 40 on switch 1, has to be replicated on switch 2, switch 3, switch 4, and switch 5. Obviously not on switch 6 because switch 6 has no concept of an MSTI. It's an RPVST switch. So we're going to go back to my trusty little text edit here. We're going to say instance, I don't know why I'm hitting enter, but whatever. Instance 2, let's look at the syntax, VLAN, and a VLAN range. So it's a range, so it can be 1, so you can see in the examples, it can be 1, it can be a range, or it can be a comma delimited list. 2 has VLANs 10 and 20. And then instance 3, VLAN 30, 40. That's it. If I do a show command, here it does have show commands. You can see instance 0 is the, we call this the IST. You'll hear me refer to that term a lot. IST is instance 0. Is our sort of root instance because it contains a lot of information that our subordinate MSTIs don't, like timer stuff that is not MSTI specific. And then we've got these two MSTIs that we just created. Now let's go back to our text edit document and we'll go ahead and replicate that configuration because I cannot be asked to type these commands in across 5 different switches. There we go. And again, we're not doing it on switch 6. That's our MST config. We're done. There is some extra tuning that we'll be doing, but for now, that's it. Right now, we go back to our diagram. We have enabled port fast. That's pretty much it. We have created the instance, so we need to make switch 2 the root bridge for it. We have created this instance. Again, we need to make switch 3 the root bridge for it, and then we need to make switch 4 the root bridge for the IST. The IST is significant because the RPVST domain, so anything that's not MST, interacts directly with the IST. It has, again, RPVST has no concept of, well, what the heck is an MSTI? I see this instance 2, instance 3, I have no idea what that means. So it has to interact with the IST. The IST is for any communications outside of the direct MST region. And so that's pretty much all we've accomplished so far. Not that that's little, but we do have some work to do. Let's go down the list. So we have to create, or we have to designate switch 4 as the root bridge for the IST. So let's go to switch 4. Right? If you recall, I said that the IST was MSTI 0. It is instance 0. So if I say spanning tree MST, got some interesting things here. This is what I'm looking for. You can configure the forwarding delay. You can configure the hello interval, the max age. This is PVST simulation, which is a more advanced topic that we're not going to go in this video. But here you can specify the MST instance. So let's go to switch 6. I want to compare this to how we configured RPVST. So let's say that I wanted to configure switch 6 as the root bridge for the RSTP domain, right? Pretend that this was all RPVST plus and we had no MST. How would we do it? How would we apply any configuration to a specific instance of spanning tree? Well, instances of spanning tree, if you remember in RPVST, are identified by the VLAN number. So I say spanning tree VLAN 30 root primary, right? And that would be all. Well, you can have multiple VLANs in one MSTI. So what we're actually going to do is we're going to provide the instance name as it says here. And that's because the MST spanning tree instances are designated by the specific instance number. So if I say MST0 root primary, and that will set it to, same concept, we'll set it to 24576. If all switches are 32768, which they are in this case, or it'll decrement by 4096. It'll decrement by one spanning tree priority increment. So if I do a show spanning tree MST 0, see, this switch is root for the CIST. That is another name for the IST. Priority 24576, CCIE 0. Now, that's switch 4, so we've kind of ticked off. I'm going to go back to this topology. We've ticked off this. Now we need to do instance 2, switch to root bridge. We need to designate switch 2 as root bridge for instance 2. So same command, spanning tree MST 2 root primary. If I do show spanning tree MST 2, we can see that the VLANs or VLANs map is there, and then this switch is the root bridge for MST2, MST instance 2. And you'll see our priority is 24578 because we have 24576, and our system ID extension, if you'll recall, with RPVST and PVST, was our VLAN number. Now it's our MST instance number. So our SysID is 2, is 24576, plus 2 is 24578, and that's a component of our bridge ID, the other being the MAC address. Now, same thing here. Spanning tree MST3, root primary. If I do a spanning tree MST3 root primary, if I can type, do show spanning tree MST3. This switch is the root bridge for MST3, 24579, because we have a different system ID extension. So now that ticks off both of these, actually. So now we get to the fun part, path manipulation. So the path manipulation part of this is what I find to be the more interesting part. So the rest of this was just, hey, let's configure an MST domain, and let's configure the root bridge, and let's understand what the IST is so we can configure the root bridge for that as well, and the MST region name and revision number. Now we're actually getting to the fun part because we're optimizing STP to work for our topology. So PC 1 to 5 should use path A here, the one in blue, and PC 3 to PC 7 VLAN 30 should be using the path here, path B, the green path. We're going to start off with the RPVST plus domain. In this case, there's only one switch in that domain, and there's 2 entry points to the MST domain. So this is STP load balancing. I'm taking traffic and I'm dividing it amongst these 2 different paths to achieve some load balancing, because maybe I don't want it all to be forced on this one path, as it probably is right now, because we haven't done a path cost manipulation. And you'll see here, do not modify port costs on switch 5. That makes it interesting, because I can no longer use this trick that I'm about to use here, which is modifying the cost on switch 6. So if I go here, switch 6, and I say show spanning tree, and I should say VLAN 10, 30, you'll see that we've got the same port blocking, Gigabit Ethernet 3.3. And before we go on, I should probably do this real quick. There are 2 path cost calculation methods, for lack of a better way to say it. So if I show the cost here, you can see, holy shoot, this is a way higher cost than 4. And it can cause some problems if you are running RPVST simultaneously with MST and you don't change this path cost method. So the way you do that is by saying spanning tree path cost method and long. So 802.1w RPVST or RSTP, actually introduced these long path costs, but RPVST Plus, when Cisco adopted the 802.1w standard to implement into their PVST Plus standard to make rapid PVST, they didn't make a requirement, they didn't make a hard fast rule that you had to use these long path costs. MST, because it's strictly compliant to the standard, now uses these long path costs So it is recommended as best practice that if you are integrating RPVST with MST, that you change your path cost values to be these new longer path costs. And you'll see they're actually kind of simpler because they're round numbers, whereas like the short path costs were like fast Ethernet cost 19, 4, and then you got 2. And then it scales up to faster links, which is why it is better. But if you use any of the PVSTs, it does default to short path costs. At least as of March 19th, 2020, the day I'm recording this, it is possible that Cisco will change this in future releases of software, but for now it is what it is. So, with that being said, we're just going to go ahead and adjust the costs of this real quick because there is no restriction on adjusting costs in Switch 6, just to make my life easier. So, you can see here, we need 1.1 and to be used for instance 2 or path A, and 3 to be used for path B. So in this case, yes, I can use VLAN terminology because that's exactly what it is. So let's say spanning tree, I have to specify VLAN. So VLAN 1020, and I'm going to say, should be doing it from the interface mode. Span cost, span VLAN 1020 cost. So this is 20,000. So say I should make it 10,000 or something. It just has to be lower than the cost of Gigabit Ethernet 3.3. I'm going to go to 3.3 and say spanning tree cost VLAN 3040 cost 10,000. If I go 1030, show spanning tree VLAN 1030 is that command. It did get cut off by the configuration sysluck, but that's what that is. You'll see that now we have a different port blocking. So VLAN 10, in my extension VLAN 20, because I also configured it with the lower cost, this lower cost, 10,000, the lower cost is better. So this is the root port into the IST. So you'll recall, here's the root bridge MAC address. And if we go to our MAC address table, because it does line up, 00CB3C40D00 switch 4. So this proves that the IST is what this RPVST domain switch 6 is interacting with, because we can see that it's recognizing that the root bridge is switch 4, which is what we set it to be for the IST. So you'll see here, right? This is the root forwarding port. List 1.1 is now alternate blocking on VLAN 30, and again by extension VLAN 40. Now we have Gigabit Ethernet 3.3, so we have effectively accomplished load balancing, if I go back here, into the MST domain. So list is checked and list is checked. Oops, I can't draw. So now we need to worry about, now we're in the MST domain, what do we do? And to do that, we need to go to switch 1. So if I go do show spanning tree here, it's going to show us all the instances that has configured. So let's go and look at what's going on one instance at a time. So let's go to spanning tree instance 2. Spanning tree enable protocol, MSTP, and let's make sure the root bridge is correct. Root ID 00CB3C72. 6V00 is switch 2. I'm looking at my paper right now. And 3CC4 4400 is, you guessed it, switch 3. So this again is a confirmation that we've accomplished our goal. List is one of the spanning tree validation commands. Show spanning tree. We don't have to specify an MST modifier because this will just list us all of our MSTIs. If you do want to specify a specific MSTI, you will have to say show spanning tree MST 2.3. And there's detail, which is a ton of detail. So we're not going to do that. We're just going to say this, and we're going to call it a day. So, Gigabit Ethernet 1.1, it's actually on both sides. So switch 6 to switch 1 is Gigabit Ethernet 1.1, and switch 6 to switch 3 is Gigabit Ethernet 3.3. But I did want to point out, right, that Gigabit Ethernet 1.1, which is a trunk, by the way. I have configured trunks on this before the video started. I did forget to point that out, sorry. But you'll see, here's what I want to point out, boundary port. So a boundary port in MST signifies that it is the end of the MST region. Whatever is on the other side of the port signifies that this MST region cannot extend further. So in this case, we can see that Gigabit Ethernet 1.1 is our RPVST boundary port. That is just something I wanted to point out because it is a kind of important topic. So let's worry about MST2, because the thing is that Switch 6 has already had its costs modified to where only the VLAN 10 and 20 traffic will go into Switch 1. So we don't really have to worry about MST3 here, but we do have to have it if the path B fails, for it to fail over here, and because the instance domain does have to match up between the MST switches. So if we go back to our topology diagram over here, we can see that path A will go from switch 6 because we've configured the cost on Gigabit Ethernet 1.1 to be desirable for VLANs 10 and 20 up into the MST domain where it hits switch 1 where we have this boundary port. We go over to switch 2, down to switch 4, and over to switch 5. So this is the important part. We're going to pretend we are a ICMP echo request packet. We are a ping that is going from switch 6 to switch 1. We have to make sure that this is one complete path and that this is the path that a ping from PC1 to PC5 will use. So if we go back here to our topology diagram, that requires that we run a show spanning tree command on the switches that we need. So let's look at switch 1. If I do show spanning tree MST2, we can see that Gigabit Ethernet 1.0 is forwarding. That's what we need it to be. Let's go to switch 2. That's all we need to do there for now. Let's go to switch 2, show span MST2. We can see, if we go back to our topology diagram here, it goes from 1.0 to 1.1. 1.1 is forwarding, and it goes from 3.0, oops, pasted that by accident, 3.0 to 3.1, and that's forwarding. So switch 2 is good. So now you go down to switch 4, show spanning tree MST2. We can see 3.1, which is the receiving end on switch 4, 3.1 is forwarding, and I need to check 1.1 and 1.2 that they're both forwarding, and we are. Perfect. So now let's go to switch 5 and show spanning tree. Again, this is an MST switch, so we're going to say show spanning tree. I'm going to do 2 and 3 this time. Oh, we have a blocking port. That's interesting. So this is switch 5's then. It's 2.2 and 3.3. Oh, well, ain't that a problem? So it's preferring 3.3 for both of these MST instances. Well, we gotta change that, right? We gotta go to interface Gigabit 3.3 spanning tree MST. In this case, to cost. Oh, wait a second. We can't change port costs. What shall we ever do? Well, if I do, we can see it here. We have cost, right? So we gotta change the cost, right? But we can't because the down requirement said we can't. So we have to find something else. Port priority. So if we configured port priority on this switch right here, it would do nothing. Oh, but I thought you said that port priority was what we needed to use. Well, it is. But the important thing to distinguish between configuring cost and configuring port priority, cost is used for local consideration. So cost is actually higher priority than port priority. So if you have a debate that needs to be settled in a sense, cost will be preferred as a factor over port priority if there is a difference. But in this case, we can't modify costs. We have to keep the costs the same. So we have to go to this port priority. But the port priority is configured on the upstream switch and is pushed down to you. So in this case, if I go back to my topology diagram over here, switch 5 would be where we would configure our costs, right? Just like I did on switch 6. I configured my cost for 1.1 to be more desirable for VLANs 10 and 20, and my cost on 3.3 to be more desirable for VLANs 30 and 40. But if I had to configure port priority, then what I would have done is went to switch 1 and configured port priority to have switch 6 desire 1.1 for a certain set of VLANs, 10 and 20, and switch 3 configure port priority, because it would push that information downstream in a configuration BPDU. So, what I need to do in this case is not configure switch 5, I'm sorry, it's configure switch 4. Because, again, if we're pushing our port priority down in configuration BPDUs, then we need to specify that on the switch is actually pushing those BPDUs down to switch 5. So in this case, we're going to say the interface numbering is different across the two switches. So we have 1.1 and 2.2 here. So we need to go to interface gigabit Ethernet 1.1. We're going to say spanning tree MST instance 2 port priority, and the default is 128, but I'm going to make it, again, lower is better, so I'm going to make it 64. And I'm going to go to gigabit Ethernet 2.2 in this case, yep. Spanning tree MST 3 port priority 64. The port priority is shown on the switch that you configured it. It's a tiny bit confusing. It's shown on the switch where you configured it, but it's pushed down to the other switch. So if I go on switch 5, I do show it span MST 2.3. It may be a subtle difference, but you'll notice that my blocking ports have changed. So gigabit Ethernet 3 is now our route forwarding, and gigabit Ethernet 2.2 is our route forwarding for MST 3, which is aligning with our diagram here. 2.2 is the forwarding for path B, and 3.3 is the forwarding for path A, both of which are blocking in the MSTIs where they're not being used, which is amazing because now we've just influenced switch 5 and caused it to load balance without configuring costs. These costs are the exact same, but because we configured port priority on the switch that's pushing configuration BPDUs down to switch 5, you can see we can influence the path selection of switch 5. So we're done here, right? We've just, by the way, we've just ticked off lists low mark here. We're done there. Let's finish the rest of the path. So now if we go back to switch 4 here, I did have to cut the video for something, but if we look at our interfaces, again, I'm going to keep dragging this back onto the screen. 3.1, good. 1.1.1.2, good. So now we're actually done, because this should, assuming our show command on switch 1, 2, down to 4 and 5 were correct, this traffic from PC1 and PC5 should now go this path. How can we verify though? Well, I'm going to cut the video again. We're going to bring up some Wireshark sessions. These PCs are configured to spec with their IP addresses, to spec with the topology diagram. And so if I ping from PC1 to PC5, so ping 10.10.0.11, I'm not going to hit enter yet because I didn't want to show you. I do have these Wireshark sessions open. My face cam does kind of cut one of them off, but that's okay. You should be able to see it anyway. So this is switch 6 to switch 1, this is switch 1 to switch 2, switch 2 to switch 4, and switch 4 to switch 5. So this going from kind of a Z formation, if you go this way, like my mouse is doing right now, this will get you the correct order that will see the ICMP packets appearing in these packet captures. And this is one of the features of GNS3. It's a feature of a lot of network emulation programs to be able to just hook Wireshark directly into the emulation. So you can see there's magnifying glasses here. So when I hit enter, what should happen based on our show spanning tree results is that the traffic will go from switch 6 to switch 1, again switch 1 to switch 2, it'll go along path A. So let's hit enter. And see, we do have a successful ping, so there is end-to-end connectivity. Then we go over here. Oh, you can see we've got all of our ICMP packets. Here's our request. There should be 10 of them. Reply, request, reply. They're in pairs. Perfect. So this is path A is configured. So if we go to our preview window here, our topology diagram, we can tick this off now. Because by using spanning tree port priorities, by using cost, by manipulating the various factors that SCP takes into consideration for path selection, we have manipulated it such that the VLAN 10 traffic, which is what PC1 and PC5 are part of, this VLAN 10 traffic is now going over path A. Now, we need to do the same thing for PC3 and PC7. If you've noticed, up until now, we've been focused on path A. Now we need to focus on path B. We need to focus on MSTI3. MSTI3, let me bring up again my topology diagram here. You can see goes from switch 6 down through Gigabit Ethernet 3.3 to 3, and then 4, and then 5. Let's go ahead and look at path B here. We need to start on, we know switch 6 is configured. If I do a show spanning tree VLAN 30, we can see that Gigabit Ethernet 1.1, which is the port that MSTI2 is using, VLANs 10 and 20 are blocked, and Gigabit Ethernet 3.3 is the root port. So we're going to switch 6. This should just forward down to switch 3. Let's check out switch 3 then. Show spanning tree MST3. That's all we care about right now. The reason this is all forwarding is because this is the root bridge. So let's switch 4 because path B goes from switch 6 to switch 3 to switch 4. So if I do a show spanning tree MST3, cool. So let's check out all these ports are forwarding. And if I go to switch 5, well, we know already that we use switch 4 here to push our port priority down. So you can see Gigabit Ethernet 3.3 is blocking, Gigabit Ethernet 2.2 is forwarding. And if I go back to my topology diagram, that seems to line up with what we need. So 2.2 is forwarding, 3.3 is blocking, because 3.3 is being used for path A. So, just like path A, path B should be complete. We didn't even have to do any configurations, but it is worth verifying your configurations so that you don't, or so that you can make sure that what you're doing actually works. So now what I'm going to do is I'm going to go ahead and close out all my Wireshark sessions. I'll stop the video and I will come back when I have the new Wireshark sessions for path B launched. Alrighty, so we're back. So I've kind of laid out, because we only have 3 Wireshark sessions that have open instead of 4, I've kind of laid them out differently. So the order now is, this is switch 6 to switch 3, this is switch 3 to switch 4, and this is switch 4 to switch 5. So it kind of goes in this order, kind of like a triangle. Or kind of like an angle from math class in school, if you guys still remember that. I actually forgot to apply an ICMP display filter, because that helps. So I'm not capturing the MST BPDUs. Just like we had with PC1 and PC5, we've configured PC3 and PC7 with the appropriate IP addresses. This is 10.30.0.30, this is 10.30.0.31, if I can click. So we're going to say ping 10.30.0.31. Again, if it goes the right path, all these will populate with ICMP requests and replies, and if it doesn't, well, either all of them won't or only some of them will. So, I hit enter. You can see we do have end-to-end connectivity because we are receiving, or we are able to send and receive ICMP echoes. Then I go over here. Oh, look at that. We now have ICMP packets on all of these switches. And if I were to do a packet capture on any one of the other links, lists would not be there, because in order for these to show up on these particular links, they would have to have gone no other path. So the fact that we have these 3 Wireshark captures open and we're seeing that the traffic is present on these individual links tells us that this is indeed following the correct path, and that switch 6 is using this path to get to PC5. In fact, if I were to go ahead and open up Just for fun, I open up one of these links. Sure, why not? I'll open up one of these links right here. Do ICMP. If I do that exact same ping again, you can see that it's not present on this at all. And if I were to do the same thing, I'll do it on one more just to prove it. It still has stopless capture. Oops, I accidentally duplicated that. If I do a start capture right here alongside one of the links on path A, filter for ICMP, and do that exact same thing again, you can see that nothing's showing up here. So this is a proof that the traffic is indeed following the path the way we want it to follow, and that it's not going along some other path. Anyway, so this completes all of our objectives. If I tick it off here. So in this video, as a conclusion, in this video, we learn how to configure multiple spanning tree regions, a brief kind of overview of what an MST region name is, revision number, instance database. We learned how to configure MSTIs to contain multiple VLANs. We learned what the IST significance to interacting with PVST, or in this case RPVST plus, is, and we learned how to tune the STP values like cost and port priority to meet our design requirements. As you can see, we ticked off all of them. If you want to replicate this lab on your own, again, there will be configurations in the description below. I will go ahead and actually copy these configurations into files and upload them onto GitHub, where the link directs you to. Again, I can't say this lab is my own. This lab is an expertly well-designed lab from CBT Nuggets, which is $59.99 a month. To get access to high quality training. Hopefully you learned something. If you have any questions or comments, leave them in the comment section below. Drop a like on the video if you liked it. Drop a subscription. I do have 2 more videos coming. Hopefully you guys enjoy MST. Do some more labbing. Yeet!